So what I've got here is just a range hood. In this case, I've got just a number of sheet metal components, and what I want to do is basically lay them out and get the nesting so I can get the quotation out for the customer so they can, understand how long it's going to take to manufacture it, as well as just taking a look at, overall sheet metal usage for this data set. So the first thing that I want to go over before I really get into that nesting space is I've got to make sure that the nesting template file has the information within it. And this is kind of a key step of the process to making sure that, when I take this data set and I send it off to that nesting environment, it knows what materials I have access to, it knows what stock sizes I work with, and it also makes sure that I don't get any kind of weird behavioral issues when I do that transfer. So as kind of a preliminary thing here to note, the nesting tool is its own separate software installation, kind of similar to the Nastran InCAD or the Inventor CAM toolset. So having just Inventor won't give you access to the nesting tools. You also have to install the nesting toolset. With that being said, it is licensed with your software. It's just an extra add-in that you have to choose to enable. And they do that just because some people may not need the nesting tools for their day-to-day. One other thing that I do want to note, I am going to be doing a sheet metal data set in this case, but it doesn't have to be a sheet metal data set or models, right? I could use this for woodworking, laminate materials, plate steel, right? It doesn't really matter what that material is or what I'm working with. The nesting tool has some functionality to bring those components in. Now, with that being said, the first big aspect to it is if I'm working with sheet metal, it's got to be flattenable. So if it's a component that doesn't flatten properly, it's not going to work in the nesting tool. That being said, things like your standard stamping functionality that creates non-uniform shapes, those are fine. But when you're working with if you say imported a sheet metal component and it was non-uniform thickness, if it doesn't flatten, it's not going to work. Similarly, if I were to work with a standard component, say a woodworking component, for example, I can take that standard component and I can add a couple of additional steps in it, and the nesting tool will understand that. So the first big thing that I have seen people have issues with is if you have, if you have your template files set to a kind of unique location, like in my case here, it's going to my secondary drive. When you install that nesting tool, it doesn't necessarily add this nest file to that template. So make sure that you have your template files configured in a way that this iNest file exists. But this is the template file that we would use for our nesting environment. From here, I'm going to open this up, and I want to make some adjustments to the actual template file itself. And that first thing that I do want to do in this space, well, I'm just going to get this session out of the way there. Here we go. Is I want to modify and establish my material library. So to do that within this nesting environment, I'm just going to bring up the process material library. And within here, the standard material is a generic material with a 0.12 thickness. If you've ever used the sheet metal environment, this is the standard default sheet metal definition. But from here, what I want to do is I want to establish a new material. So to do that, I'm just going to click add. And then within this value here, first thing I can do is define what the material is. And then also what my thickness of my material is. I can categorize this, steel, and in this case, I'm going to put CNC. And the reason I'm putting a category of maybe CNC is one of the steps during this process is, excuse me, I also want to potentially define my item separation. So in this case, if I know I'm using a specific, CNC routing tool to cut these parts out, I can define that. Or if I were doing like a laser, I might want to define the kerf thickness or the kerf width as the actual laser kerf plus maybe some small amount for potential offset. or finishing after the fact. And so this is going to play hand in hand with how the nesting functions, but also thinking about what my manufacturing process is along with it. So the first thing, again, the material, and then the thickness of that material, and then categorizing it just helps to keep things organized within the space. I don't necessarily have to define the density of this material. I can do that if I choose to. On the packaging side, or the next step of this process, after we've defined what material we have, we can then come in and define what types of packaging we have with that material. So in my case, we're going to create 3 different sizes in here. So in my case, I'm just going to name these based on their sizes. And all I'm going to do is just adjust the values to make sure that they understand the size of that shape. Mark. Foot. Can't type today. There we go. And from here, I can just add as many of these as I might need. So in my case, I've got a 4x8. And again, I'm just going to adjust the dimensions in here. And then lastly, I'll add an 8x8. So if I've got a really big table, I can define those. Now, one thing that I will mention here is this would be where I would add the standard sizes that we use. During the actual nesting creation process, if you had, say, some scrap pieces that were left over from a prior cut, you can add those into the packaging for that specific file so that it uses it for that specific nest. And that's really easy to do. It's just this exact same location. I would just add one in for that specific document. And then that would in turn, try to use it if it could. Lastly, on the nesting side, the options within this space, the big thing here is what types of orientations we allow. And also, if I'm working with like a wood or an orthotropic material that has grain orientation, I can specify where that grain orientation is per that material within this space. The deviation and increments, if I leave these at 0, it's just going to allow the parts to rotate at any angle that they might want to rotate within the space. And again, the other part of this being the increment, if I wanted it to not rotate them to specific values, I can do that as well within this environment. So this is, kind of the generic steps of this process as far as defining how I want these to function. The last thing about my material packaging, or the different types of material that I have access to, I can specify the trim boundaries or the safe frames around my material. Say I'm going to, fasten this to the table that it's being cut on. I can specify what range around that material I want to use for holding that material steady during that process, and essentially just define that trim boundary around the sides of the part. And the nesting will take that into consideration. So again, each one of these can be defined, and within that shape, we can lay all that out. And again, we can also define each nesting's boundaries per material within the space. So now that I've done that, I'm going to hit OK here and store that in my template. And now that I've done that, I'm going to close out the actual template file. And within this sheet metal data set, and as a general note here, I could do this from a part file, or I could do it from an assembly like this. If this assembly had rivets or weldments or weld nuts or anything else inside of this space, if they were non-nestable components, the system is typically smart enough to figure out this isn't something that should be nested. If the thicknesses don't jive with the material library, or the shape of that part doesn't make sense, say it's a revolve, for example, and it'll just exclude them automatically. In my case, I didn't add any of that material in here just to keep this data set simple. So from here, all I'm going to do is right-click on the assembly file in the browser, and I can tell that I want to create a nest. From here, excuse me, from here I have 3 options. I can either choose one of my template files, and as far as the template file creation is concerned, I've seen people that they've set up the materials in the templates, and they set them up where the template file is got either by material, where they're doing it for, I've got all of my sheet metal materials in one template, and then a plate steel and then wood. I've also seen it where they do all of their templating or nesting calculations based on what machine it's going to. So if I have a laser burnout table and a CNC, I can create templates for each one of them, and then when I run that, I would have access to just that set of tools for that specific machine. In my case, I just updated this. Again, obviously, as I would be working on these, I would want to make sure to select the correct template. The other two options allow me to just add to an existing nest that I've already got open, or send it to a file that already exists. But in my case, I don't have anything, so we're going to choose that top option. When this runs, in this case, it does see the material and the thickness. I'm going to say no to this right quick. Let me check to make sure. Still come mild, 0.2. Shouldn't matter. I'm going to clear the category for a moment. For whatever reason, it did not pull the link to that. All right, let's try this one more time. Create nest. I must have typoed or something when I was creating this. I'm gonna check my. Just one more time. I don't typically have to do the edits to the don't typically have to do the edits to this. This shouldn't matter. Metal. Paste. Okay, and save. All right, let's try this one more time. Create nest. I don't know what's going on there. So basically what it's telling me is that the materials in those components and the materials in the library that I just created don't match. And I don't know exactly why it's doing that. Because they are the same. Interesting. I'm going to go change one more setting. I have an idea what it could possibly be, but I don't want to spend too much more time on this. Standard. I did this earlier. I didn't do this, so I'm not sure what changed. This is an inventor, and the material name for inventor is steel. You typically don't have to define these values for the provider and material name. It usually will pick it up on its own, but I'm going to add them in just to see if it forces that system to correctly associate create nest. Yeah, there we go. Okay, so for whatever reason, it didn't want to import directly against that data set. I'm going to hit OK on this, and we'll see it brings in those three components, and it brought those three components in and essentially colorized the flat patterns per that material. And if I expand this open on the model browser, we can now see in here we've got the source material being that source assembly file, and then the various components that made up that assembly. If I right click on the assembly itself and I go to the providers of this, we can see that it's coming from the inventor assembly. If I go to the geometry sources and go to properties, this will bring up some information about each one of those objects. And so within this space, the first thing to note here is that it does auto kick out the quantities of each one of those components. So we've got 4 clips and then 1 each of those other 2 components within that assembly itself. Same thing in here, where within this space, we can just specify the options for, is it allowed to be rotated? Can it be rotated at which angles? Can it be mirrored or flipped over? And all of those various settings that we want to control for the nesting layout that we're about to create. If I had other objects that I wanted to import in here as well, all I need to do is go to sources, and then I can select a source file to import additional objects in here. So in my case, I'm just going to go to my demo drive and navigate down to my parts. And I've got an extra sheet metal part that I want to load in here, and it will import that and add that source file to the object. Now, in this case, it's not showing a parent because it doesn't have a parent object. Additionally, with this source file, it doesn't know how many of these I want to add. Excuse me. It doesn't know how many of these I want to add to this data set yet. So from here, I've got my essentially the source objects that I want to work with. So from here, I can then tell it I want to create the nesting study. I can give it a name and a comment. And then from here, I can just specify the overall job quantity as far as how many of these I need. So in my case, I'm going to tell it I need 2 of them. And then from here, I can specify how thick my stack is that I might be cutting through. So since I need 2 of these, if I were to stack this to a stack size of 2, it's going to obviously subdivide as necessary to manage that nesting properly. On the shape side, it will show each of the files that are going to be added to this specific nesting. If I wanted to say remove some of these components out, I can do that. On the packaging side, this is where I would specify what materials I might want to use for this specific job. And so in this case, a 4x4 is probably not going to be large enough to get all these parts on it. So all I'm going to do is just add in these other 2 packagings. I'm going to specify that I have an infinite quantity of them accessible to me. But again, if I wanted to add, say, like a scrap piece before I get to this step of the process, I would just go up to the material library, add that packaging, and then at this step of the process, add that scrap piece in to this list and then specify that I have just 1 of them or however many of them I have. Additionally, I can change the order of these so that it tries to use the material in the order as specified. Or you can come down here and say best mix or best size to try to, best optimize the usage. In my case, best mix won't work because I didn't specify the costing of each one of these sheets. So by using the best mix, it's going to take essentially a calculation of the sheet itself plus the cost to get the best usage. In my case, I'm going to use as listed. So it's going to try to use a big sheet first and then work, or no, I want this the other way around. I'm going to use the smallest sheets first and then work my way up to the bigger sheets as necessary. Some of these parts are quite large. Lastly, in here, I've got a global parameter regarding where I want to start the nesting from. So in my case, it's going to put everything in the lower left corner and then specify just how long I want this to run at maximum. So if I have a really large set of files, I can tell it how long to calculate. And beyond that, how do I want it to try to optimize the remnant of that material? And so if I had a really big data set, I might want to consider increasing the time from 300 seconds to maybe 600 or 900 seconds, so it can take a little bit longer to calculate how long it takes to get to a final step. Okay. So from here, I'm going to click OK. It's going to generate that nesting study and then calculate the objects and then generate the overall nest for this design. So in my case, my largest piece is actually bigger than what my nesting can allow. And so it nested together the individual pieces that it could put together, but the rest of the components are, in fact, that last piece is actually missing, which is why we're getting an error here. If I right click and go to should show me, where's my error? There it is, range top may not fit on any nest. So if I linger on it, it'll show me that warning or error. So in my case, I know that that piece is too big. So I'm gonna have to add in another size. So in my case, I'm just gonna do like a 10 by 8. So for this specific job, I'm gonna buy one piece of material. So all I'm gonna do here is just add a new packaging and then specify that size. So we'll do a 120. And add that in. From here, I just need to edit the existing nest. So I go to properties and then add that additional packaging. It was already added. Let's take that one out. And in this case, I'm going to tell it that I have 2 of them only. It's not infinite. Tell it I only have 2 of them. And we'll put those at the top so that it tries to use that first, since I want to get all of it cut out of that sheet if I can. And then as soon as I click OK, it resets the simulation. Ooh, that's unique. What are you doing? Let's do this one more time here. If I reset this to infinite, is it? I don't know why it's stacking them like that. Property is. $96 by 100, so it knows the size. Let's move this down and see. It corrects itself. That is so bizarre. I don't know why it's stacking these 2 parts up. It did not definitely did not do that before. Nesting study. I'm just going to change the job count to 1. No. Set this to 2 and set the stack size to 2. And that should obviously reset it so that it can only cut to 1 layer thick. There we go. Yeah, I'm not sure why this specific component was trying to overlap on itself. It definitely should not have been doing that. So in this case, again, right as it stands right now, because of the order that I have for my material, it's trying to use the 4 by 4 sheets first, then increase size to the larger ones. But in all reality, I can get rid of this sheet. So to do that, I'm just going to go into properties here and remove that packaging from the set. And in doing that, it's now going to recalculate, replace these components, and start to use the next size available. In my case, I don't need the 4 by 8 either. So again, I'll just go in here and remove this one from the stack as well. Since I have such large components, and every time I adjust this, it just rebuilds the nesting within that space as required. This is a live file, right? This is essentially a child to the assembly. So if I were to go in and update the componentry that makes up this design, add holes, remove geometry, update the counts in that assembly, this data set would automatically adjust as necessary to accommodate those components. The last piece of this process, as far as working within this environment, is I need to get the files out of here. So as it stands, this nesting file, I'll do a save. And then from this, I want to take these sheets and output them to some formats that I might be able to use downstream. So kind of the more common one would be to just do a simple export. And then from here, I can export the sheets as DXFs. When I do the save as DXF, There is an export editor where I can control things like what layers objects are being pushed to, some specific values that I might want to control. If I do a preview here, we'll see the output data from that individual sheet. From here, I'm just going to hit OK and generate that file. And I'll repeat that process to sheet 17 as well. Each time the nesting recalculates, every time I was going into the properties, it updates that sheet number. So that's why we're seeing that data duplicated as such. So from here, I'm just going to save this down into my sheet metal folder. Save that one. Save. And okay. Go. And if I wanted to open these up, right, I can just navigate to them and open those files. So let's give this a second to open it up in AutoCAD so we can take a look at the DXF. And so there's the DXF file that gets generated from the default configuration within the default configuration of Inventor, the nesting tool. From here, it does mark each file. This data does get layered on its own. So you can see in here the the dimensions are on layer 1, the objects are on layer 0 within this space. So everything is all laid out as necessary to potentially grab this information and push it into simple CNC routing system. The alternative would be to take this data and in turn work with it within Inventor and use the Inventor CAM tools to work with these objects. And so there's a couple of options available with this model. I need to right click on the sheet itself. I can create 3D models from this. And in this case, what I want to do, because I'm not worried about the individual components, I'm going to tell this I just want to create a multi-body part file, and I'm going to tell it to include the stock. So in this case, it's going to give me that stock block wrapped around it. I'll hit OK. It's going to churn for a moment, and then it's going to generate that IPT file with all of my components laid out within this space as they were laid out in the nesting environment. From here, it would just be a matter of going into my CAM side, hitting my setup. From here, I can spec out the machine type, my model orientation, reposition it. In my case, the models are these specific objects. So I'm just going to work my way around selecting those. And then on my stock side, I have a solid that is my stock. So I can select that within the space. So from here, it would just be a matter of basically just running a number of 2D contours around these components with whatever tooling I wanted to use. Now, in my case, because I did this with a 1/4 inch part spacing, this wouldn't necessarily be truly ideal for like a, doing cutting with like a laser. But within the setups inside of Inventor, we can change the machine operation type to cutting. And when we do the cutting in here, we would specify, what our laser cut profile space is using the 2D profile command. And within the 2D profile command, we can just select each one of these profiles. And then from here, we can specify our tabs, how far apart we want them. The heights we don't necessarily need to worry about in a 2D passing side or 2D contour side. But then from here, do we need to leave stock behind for deburring operations? And then lastly, do we want to do lead in and lead outs? In this case, the kerf is probably not configured quite properly, but we can see there the cutting that it's going to do around each one of these parts. So from here, I could just output this to CNC and be pretty well off to the races. So the nesting tool, the first big step, as I touched on, making sure that the template file has your materials as necessary inside of it. Making sure that you know what material type I'm working with, what the thickness of that material is, and then also what the associated Inventor material is. Once I've done that, it's just a matter of using that template to import the objects. And when we use that from sources tool, we can import assembly files and all the sheet metal components within them, or extruded material within them. We can also import individual sources as necessary to try to fill up a sheet as required, or as parts are necessary. Once we get to that step, if we did have extra stock material that we wanted to scrap pieces that we wanted to try to utilize, we can add those to the material library, or to the process material library, and have it use those as necessary as well. Or if we have to order specifically larger sheets and things of that nature, we can do that. One other thing that I didn't really delve into here, it does show you the total efficiency of that material. If I did have costing in here, it would show me the package costing, and then overall essentially what the utilization of the nesting material is based on it. So in my case, I'm using up 61% or 40% of this total piece twice over. So it's giving me that those values for the estimated costing for this specific sheet. Additionally, the total efficiency of this job, total number of parts, total sheet count, and so on. And again, if I had my nesting costs associated in my material library up front, this would definitely kick out more accurate results to what the total time is here. Now, with that being said, this isn't giving me travel time on the laser, and that's where this part can come into play. Getting into that CAM side of things, looking at the setup sheet, for example, this will show us the total travel time that it needs to cut for this component, and what operation, estimated cycle time, and total travel time. So for getting quotations out, this is a really easy process. The biggest thing is getting that setup done up front, just to save you a lot of hassle getting it generated, right? And then once it's done, you pretty much set it and forget it for the future usage. So I got done a little bit faster than I was expecting. Do we have any questions from the group?
Well, Keith, we had 2 questions come in that pertained to the materials. I believe I answered them. I hope I answered them adequately enough. But basically concerns on, can the material library be used for the selective materials or packaging, and then can materials currently created in the sheet metal environment be imported?
Yeah, so
that whatever it's assigned is what comes in.
Yeah, exactly. So if I go open up just the nesting file again here, in that process material library, we can add from providers. We can select specific materials in here. So if I were to say I'm just going to grab a wood material here. It'll add in. It does a bit of the steps, but it doesn't necessarily like import specifically from a given file. As far as I'm aware, there's not an easy way to do that. But yeah, you would just essentially build up, whatever materials you might need for your templates. There's no easy way to grab from an existing object. Now, another question that just came in was, can I pull in DXFs and work with them? Yeah, if I go to sources here and I go source out a specific part file, it'll bring that in, but it doesn't know how thick that material is. The other thing that does matter with that profile shape is it does have to be a closed loop. I just grabbed part 2. Let me go look at that real fast and make sure the part 2 DXF isn't broken. It should have been a closed profile, but I'm not 100% certain. Yes. Yeah, so this has the bend lines in it, which is going to mess it up. So in my case, I'm just going to get rid of those. This was an exported like circular part that Kendra was having problems with a couple weeks ago. Can I save this now? Is it going to freak out? Save as. DXF. There it is. Here we go. Don't care about that. So in this case, I'm going to delete this, delete that source, and I'll re-grab that new DXF file that only has the continuous loop around the outside of it. And then you'll see there it brings it in as one object. So what really matters inside of the DXF files is when you bring them in, when you bring them in, it has to be a continuous singular profile. If it has multiple loops in it, it doesn't know what to do with that profile shape. So it might take a little bit of cleanup on the DXF side in order to bring them in properly. Beyond that, this doesn't know what quantity you need, right? You would also want to specify what source material this is. So if I go to my sources here, I would want to specify which material I want to cut this with. Yeah, so when you generate the material library, you would specify all of your template materials in here and have them associated to the same material and thicknesses that you would have from your sheet metal objects. When you do that, it will then link them together. One other thing that does happen, if I don't have the process material library set up, which actually happened, that quote unquote error that I was seeing, it was basically saying, hey, there's not a material in here that matches what we have in Inventor. Do you want to create one? And when it does that, it just creates it with essentially the same as the generic material settings. So it'll be like a 4x4. It has no costing associated to it. It doesn't know what your safe frames are. So it doesn't know, basically any of the real specifications for that material, which is, again, why you want to set it up front, so that you don't have to go through all those mouse clicks every time you start a new nest in space.
And Keith, real quick, I want to touch base on that situation you had where the profiles were overlapping. I was trying to comment, but my microphone driver decided to die at that time. So by the time I got it running, you had moved on. The one time I had that happen was with third-party sheet metal geometry, and there was something wrong with the flat. I don't know exactly what it was, but when I finally got it able to regenerate the flat, it worked.
Mm-hmm. Yeah, that's the biggest gotcha there. And one of the questions was, can I nest without specifying a material? Absolutely. I don't necessarily have to build any of this stuff up, but for true cost and quotation and that sort of thing, I can get all of that data embedded, and then I don't have to worry about it. But this material ID here is just a raw piece of, in this case, it's like 196-inch square, that I could just as easily update that packaging when I import from the raw part and then nest out my quantity counts as required. Like in this case here, I've got just this one part loaded, and I don't know the size of this, but if I go to the actual source properties, geometry sources, this will show me it's a 38 by 2. So if I wanted to see how many of these I could fit on a sheet with a specific curve, I can basically just go in and create the nest study, specify that I have one sheet thick and I need, I don't know, we'll say, give me 40 of them, and see if I can get 40 on a single sheet.
The next question is a very good question. Can a nest be created from an IAM without opening that IAM? So the assembly.
Yeah, so when I go to the sources here, this is locked up on me. Wait a second. Delete that nest. The part doesn't fit, so it freaked out. There we go. In any case, yeah, if I don't want to open the files, I can always just hit the source files here and then just go grab any assembly file that exists. Even if somebody else has it open, it will allow me to work on it within this space. Now, obviously, as they're updating their files, you'll notice little symbology over here in the nesting study space that's showing that it needs updated. Basically the same kind of lightning bolts and symbology that you're familiar with when if you're working on an assembly and somebody has a subcomponent or subassembly inside of it open, right? This is its own unique file, so you can import the documents as necessary. One other thing too is if I do have standardized components, say for example, so I've got this L-shaped component, but maybe I don't want it to cut inside the L. I can create a block of secondary extruded material inside of that part file. And then in the right-click menu, I can specify that that is the nesting profile shape. So just to kind of give you an example of that, I'm not going to go through every single step of this, but just to kind of give you the idea here. So from here, I'll just generate a second sketch that is the actual profile shape that I want to work with. And in this scenario, it doesn't have to match this at all, right? I lined it up to the corners, but I could have made it slightly larger if I wanted this part to have extra, even more material around it for secondary process or whatever. Doesn't really matter. But now that I have that sketch defined, if I right click, I can come in and specify that this is the profile I want to use for nesting for this object. So when I do that, it will then in turn pull that geometry for this component in the nest space. So from here, I can tell that I want to create a nest. Oh, probably help if I closed this. And so right here, I didn't give that part of material, and I gave it a thickness that I don't have in my stock library of materials, and I only built steel mild 0.2 thick. So this is the dialogue you would see during the standard workflow for this data. And in this case, it's just saying, hey, do you want to create and map a new material to this object? And so in this case, I'm going to say yes. It's going to create a new material in the library called generic 0.12. And if I go up to my process material library, we can see that generic 0.12 that got built. Although it didn't grab my nesting profile. Let's just take it to the next step here. So we're going to create a new solid. We're going to tell this to use for nesting, just to be used for nesting. Save the file, update everything, save the file. Refresh it. I don't know why it didn't grab my part. I feel like there's probably some really simple step that I skipped over because I'm trying to go quickly here. But typically that's all you have to do is you select the object and you specify that profile shape. And you right click on it and you say use this for the nesting. So the last one other question here is when you have oddball shapes, it doesn't keep track of that nesting profile in the material library here. It's going to be just the raw rectangular profile shapes. You do have the ability to come in with the packaging and specify if it's a roll or rectangular, but those are the only options you have available for the shapes of the nests. So realistically, you would have to, as far as I know, there's not a way to, at least yet, to modify the shape. Kendra, do you know of a way to do that?
No, I was actually looking for that the other week looking for some kind of way to utilize scrap or reclaim it in another template, and I couldn't figure out a way either.
Yeah, the only way that I know how to do it is you would use just the actual shape of the part. So if you had a part that had rectangular cutaway out of it, and you wanted to use the rest wrapped around to that shape, unfortunately, there's no way in the system currently to do that without doing some really, I don't even know, you have to do some really bizarre things to try to make it work. But even then, it would be, as far as I know, it wouldn't be really feasible.
There are two other questions that came in. One of them, I'm not sure exactly what it's asking. Is there a remnant tracking database that follows this?
No. So the remnants would just be the size of the parts per instance, and that data is just stored in that one. The size of the remnants is just dimensional data stored in the object itself. So that would be something on the users to try to track and manage as far as what material is left over.
And it looks like the last question deals with iProperties involved in the nesting process. Can the custom fields of part iProperties be utilized?
I guess I don't understand which properties you would want to use. The one parameter value that it can pull in, you can create a custom nesting thickness for a component as required. And that nesting thickness can be used for like a standard part, for example. The extruded, I'm going to say your D3 or whatever value you use for that first extrusion doesn't necessarily have to be the dimension that it's using for the object itself. And that might be the actual dimension problem that I'm having with my part, why it's not going through it, because it doesn't know, what the actual dimensional thickness of that model is. And it's just a matter of going into your parameters and naming it. And I believe it's nest underscore thickness. I'd have to look it up. It's not one that I have memorized. But yeah, you can build custom parameters. But as far as iProperties are concerned, I'm not sure what iProperties you would need in the nesting environment. Nick, do you have an example of what iProperty you would be hoping to use?
We'll get a new question. Can the drop material be saved in a library for future use? And I'm guessing that's probably for the scrap utilization that we were looking at.
Yeah, I mean, other than potentially opening up the nesting and keeping track of it, or using like a third-party tool to track what scrap materials or what drop material you have left over, unfortunately, there's not an easy way to do that in the system right now. It doesn't have any kind of there's no easy way to do that as of yet. And yeah, we can always table that discussion, Nick, about iProperties in the nesting. There is the ability to use iLogic within this space if you did want to, potentially output data to like an Excel file, for example. Within the nesting itself, all of these values are extractable via the reporting. So each of the source materials, all the properties, and so on.
Nick responded, said he'll have to get back to us on that. And that goes for just about anything that wasn't answered in today's webinar or any kind of questions like that. You can definitely field them to us after the webinar is over.
Yeah, as far as importing Excel materials, there's not an easy way to do that in the material library to like bulk create them, unfortunately. There might be a way to do it programmatically, but as of right now, there's not a way to do that.
Well, looks like that might be it. I don't see any others rolling through.
Excellent. And again, if any other questions do come up in the future, if you do want more additional, Q&A or training on this, that's definitely something we can help you out with and get you going.
Okay, well, thank you guys for the presentation, and thank everyone for attending today. Like Keith said, if you have questions you think of later, you can simply reply to that confirmation or reminder email you receive from GoToWebinar. We can get those to whoever needs to be sent to help you with your questions. Once again, a short survey will just pop up as we close down today, and also a reminder that you will receive an email tomorrow, which will contain a link for the recording of today's presentation. And with that, we'll close down today. Thanks, everyone.
Thanks.